Imagine a world where AI doesn't just predict the next word, but understands the full depth of human thought, reasoning, and even the subtle logic beneath a single sentence. This isn't science fiction. It's the frontier of what's happening right now in large language models, specifically, the shift from pattern recognition to reasoning. For years, we've celebrated models like GPT-3 and GPT-4 for their ability to generate fluent, coherent text. But here's the truth, they're not thinking. They're mimicking patterns at a scale so vast it's almost indistinguishable from intelligence. They don't understand the meaning of a sentence. They predict what comes next based on billions of examples. But what if we could teach them to think? Enter the new generation of reasoning models, models that don't just generate text, but reason through problems step by step, like a human would. And the key to this transformation? Chain of thought prompting. Let's break it down. Chain of thought prompting isn't just about asking an AI to show its work. It's about restructuring the way the model processes information. Instead of jumping straight to a final answer, you guide it through a sequence of intermediate steps. First, I'll consider the premise. Then, I'll identify the logical implications. Next, I'll eliminate inconsistent options. Finally, I'll arrive at the conclusion. This simple shift, adding reasoning steps, has been shown to boost performance on complex math, logic, and even multi-step reasoning tasks by over 30% in some benchmarks. Why? Because it forces the model to unpack its internal reasoning process, reducing the likelihood of guessing. But here's where it gets deeper. Chain of thought isn't just a prompt engineering trick. It's a structural change in how the model learns. Researchers have discovered that models trained with explicit reasoning examples during pre-training, where they're shown not just answers but full chains of logic, develop a kind of internal reasoning architecture. These models don't just mimic reasoning, they learn to reason. This is the difference between surface-level pattern matching and deep structural understanding. And now, we're seeing models that go even further. Enter self-consistency and tree of thought reasoning. Self-consistency is a clever technique. Instead of generating just one chain of thought, the model generates multiple reasoning paths, then votes on the most consistent answer. It's like having a team of AI reasoners debate and converge on a solution, reducing errors from randomness or flawed logic. But tree of thought takes this to a new level. Rather than a single linear path, the model explores multiple branches of reasoning simultaneously, like a decision tree. It evaluates different hypotheses, backtracks when contradictions arise, and prunes dead ends. This is not just prediction, it's search. And the results? On tasks like the Advanced Mathematics, AMC, exam, models using tree of thought have outperformed even the most advanced baseline models, reaching scores that rival top human students. But here's the real breakthrough. Reasoning is not a feature, it's a capability that emerges from scale and architecture. Recent research from Google DeepMind and OpenAI shows that as models grow larger, especially those with dense, hierarchical attention mechanisms, reasoning doesn't just improve incrementally. It emerges. A model with 100 billion parameters might still struggle with basic logic puzzles. But at 1 trillion parameters, suddenly, it starts generating coherent, multi-step reasoning chains without being explicitly trained to do so. This suggests that reasoning isn't just something we teach. It's something the model discovers when it has enough capacity, enough data, and the right internal structure. Now, let's talk about what this means for the future. We're not just building better text generators. We're building systems that can solve equations, debug code, analyze legal contracts, and even assist in scientific discovery, by reasoning through complex chains of logic, not just retrieving information. But there's a catch. Reasoning is not flawless. These models can still hallucinate steps, get stuck in loops, or make subtle logical errors. They don't have real-world grounding. They don't know what a triangle is, they just know the statistical patterns associated with a word. So while we're making incredible progress, we're still far from artificial general intelligence. But we're getting closer. And the most exciting part, this isn't the end of the road. Researchers are now exploring reasoning with external tools, integrating models with calculators, code executors, and symbolic reasoners. Imagine an AI that doesn't just write code but executes it, checks its output, and iteratively improves it, like a real programmer. Or consider models that can self-correct their reasoning by asking, does this step follow from the previous one? And validating it against a logical framework. We're not just making smarter AI. We're building systems that can learn how to think, not just what to say. So what does this mean for you? If you're a developer, this means you'll soon be able to build applications that don't just answer questions, but solve problems. If you're a student, you'll have tools that don't just give you answers, but show you how to think through them. If you're a researcher, you're entering an era where AI can assist in hypothesis generation, experimental design, and even peer review. The future isn't just about faster or bigger models. It's about smarter reasoning. And that's what's happening right now, on the cutting edge of AI research. So the next time you ask an AI a question, don't just look for the answer. Ask, how did it get there? Because the real breakthrough isn't the result. It's the process. The age of reasoning AI is not coming. It's already here.